So, sorry, audio is going to be awful because I'm just on the laptop today. But whatever, just one screen. So, it's been a week because I had a bunch of other stuff to do, and let's see if we can recover where we are and try to do some meaningful progress within 15 minutes or so. Oh, yeah, we actually did that like neural network thing here, neural network. So, before all that stuff was done, what was the output? Encoded shape, input encoded, output references. There we go. Yes, I think these were input encoded through input encoded shape. Yeah, so these were 75 kind of windows or samples, and then 5 is the window size, 20 is the D model. Yeah, the D model exactly. Window size 5. Yeah, so essentially each word is like made out of these 20 things. Which are this here. Okay. And now, what we wanted to do, so input encoded, basically I have 75 exactly, and each of these 75 has like 5 elements, right? So, and here we have 75 like outputs, and those match, right? So essentially, yeah. So this is basically the 75 different things, or the 5 different words. Five, one, two, three, four, five. So these are 5 words. Each of which is represented with 20 dimensions data. And for these 5 words, then you kind of have input encoded 0 and input reference 0. Basically tells you that those 5 elements correspond to that one element. And I wanna now be able to train these to train a to train a simple neural network on that information. And for these, Ghostwriter gave me something which is a neural network, a basic one. And this neural network essentially what it's doing, input shape. So there's the forward move, the backward move, however that you know rel prime. Those are technicalities, I guess, of just the activation function. So what I don't know if those passes work or not, but essentially I have the input shape. What is supposed to be, right? So the input shape is used. Maybe can you maybe Ghostwriter can help me. Can you explain me how does the class in NumPy is supposed. So explain me how uh, how am I supposed how I'm supposed to use the numerical class in main. Uh, explain code. So create an instance of another class specifying the input shape. Yeah, okay, but I don't know what the input shape is. So the input shape. So what is the input shape? That's not the input shape. It shouldn't be 75 because essentially I'm iterating. I'm iterating. No sense. That makes no sense. I think. Let me just do this again. So Ghostwriter build. So give me code. Give me code for a simple neural network that can work with my input uh, samples. The data shape is as follows. My input is a collection of 75 samples. Each sample has five, sort of like has yeah has a 5 by 20 tensor, um, and it's associated to a single integer output. I want the neural network to learn the relationship between the 5 by 20 tensors and the single integer. I think that's easy because I'm not so sure. That's definitely wrong. Like it shouldn't. You shouldn't just be. Yeah. So let's see. Maybe let's initially even just not be picky, as in like. Can you give me some example code on how to train and use this neural network you just shared? That's the problem I have. I'm not so sure 75 needs to be in here. Shape. Why is the input shape? Why is the input shape in the code you shared before? Okay. Okay. So actually, it does the whole thing. It trains like there's like 1,000 iterations. It trains through all the data. Okay, maybe. Yeah, maybe it's forward. Okay, but I mean, this is kind of what I think was not working well. So class neural network can be defining it at the top maybe. Class neural network. And here now I'm gonna basically at the end. So now I'm just gonna neural network this input shape. Yeah, the funny thing is this somehow taking this from the history of the code. I have the feeling, but whatever. Training data. First of all, let's just see if that works well, regardless. Because it doesn't, right? It doesn't even work well with this like randomly generated stuff. So it says the error is 19 occurs for a method. There must states that shapes and arrays are incompatible for metric simplification. Um, if you want to reshape X, you can change line to do that. To do the transpose, you can such a requirements. Oh, how are we even gonna do these? Um, because now I need to dig into how the neural network actually works. Yay! But yeah, actually that's the point, right? So line 19. So there's a dot product hidden size. Not so sure. Okay. Can you explain? So can you explain this, please? Can you explain this? It's just doing matrix multiplication because it's just taking, it's just doing. But that's the point, is that it's taking all the data in of all the training examples, and that's not the point. The point is, I. So my intuition tells me that 75 shouldn't be part of the shape. My intuition tells me the shape should just be 520, because you basically input something that's 5 by 20. Um, you know what I mean? And then this hidden size just kind of makes no sense either. This is totally messed up. This is totally messed up. Let's get into neural networks, because we actually have to do this, because this is shit. Um, First of all, the input shape is basically, okay. So let's just start here. So let's get into neural networks from scratch. Um, the input shape of a neural network, should it include the whole training set? I don't think so. My assumption has been so far that the input shape reflects the shape of one training set element. You know what I mean? It's like it's one image, right? Like a set of pixels. You know what I mean? Um, so explain code. We want just the default mode. So your assumption is correct. The input shape of neural network refers to the shape of one training set element or sample. It describes the dimensions of the input data. If in the network, okay, exactly. If an image, three-dimensional array, height, color, channels of one image, exactly. So how exactly? Because it's essentially what the neural network is doing is trying to just do um, so what the forward pass is trying to do is just multiply. It just does it. So there's a random. So there's this random thing in the middle. So you multiply by these, yeah, and then you adapt it until you get the actual data exactly. So the hidden layer. Okay, so 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 knowing these, um, how do you specify the shape of, say, my input shape is 520, and I know my my output here is just a single integer. Well, it's not. It's actually not. It's basically probabilities, right? It's just a least probabilities for a one-dimensional vocabulary size n, whatever size n. So, let's explain code, but just default, right? So because it's actually a neural network is very simple, right? It's just like let's try to find that kind of linear that correlation by just taking data, kind of finding an element that multiplies and thus gives you an output and correcting for the difference and keep doing that, right? So here it says, what does it say? This because I don't like that thing with like 128 or just the fact that the hidden size is basically shaped as in like how many hidden nodes do we have, I guess. Despite the shape of hidden layer in a network, you need to consider the number of neurons or units in that layer. The number of neurons in the layer is a hyperparameter that can adjust. In your case, since your input shape is 520 and you want the output layer to have a list of probabilities over a one-dimensional vocabulary, you can choose the number of neurons in the hidden layer based on the complexity of the relationship between your input. Common practice is to start with a small number of neurons and gradually increase the size if needed, but there's no specific formula to determine the optimal number of neurons. Okay, experimentation. Here's an example of how you can define a with single hidden layer using input shape 520 and an output layer with size n. Okay, so input shape, hidden size, output size. So that's the neural network thing that we have. Hidden size 128, 520, and output size n. So maybe take that out, copy this neural network, copy it here, and then the example usage is not these, but it's basically say let's see if we can first create it all. So the neural network example usage is basically input shape 520, hidden size 128, and output size is essentially the vocabulary size. How do I know that? English vocabulary. So it's the English vocabulary that we get there, right? That's the output size. Because essentially you want, yeah, you want to just have a probability distribution of those things, and you just want that to be. I mean, that's what you. That's I could also just design it so it just spits out one thing. What is the advantage? So what is the advantage of designing a neural network so that the output is a probability distribution versus just a single output? Um, because the thing is, not explain code, default. Because the thing is the following, right? So the thing is basically, if you if what you have is in the training data you actually have just a single element. You don't have a probability distribution, right? So why would you not do that? Like, doesn't understand output is a probability distribution has several advantages. Yeah, but my point is you're giving it okay. You're giving your but I get it. So you're the thing is you're giving it just a single element from a training perspective, right? But then uh, probably you want to calculate in the loss function so that like with the probability distribution, you know, you can have a certain confidence level you can put in there for you to consider something like a correct one or not. I guess it could work. I guess it's just fine like this. I'm thinking. Mm, let's do that. Let's just use the signs. First of all, let's see if that just at all. Okay. Softmax is not defined. Softmax is not defined. Is softmax used anywhere? Ooh, sorry. Softmax. I believe should have not deleted that. The softmax thing, and I shouldn't actually. Should just have deleted these and put in the new one, and then this example usage stuff. And I apologize for the quality of the sound because it's probably awful. So we'll get rid of the. First, let's see if that just works at all. So this will be English vocabulary dot size. Boy, have a red face. Anyway, should I just use length? Actually, I have to switch now. Okay, so it's created the neural network. At least that is it's done that. Um, Now, can I just do a simple, like, what if I just do a simple forward pass? What does it do? Forward is self, and then it just gives you the x, which is basically one element, right? I'm just gonna try this. I'm just gonna do. I'm just gonna do nn forward, and I'm gonna give it forward pass input encoded like say 3. Is that the right method? No, it's just okay. It's just forward, and then it needs the neural network itself, and then x. Okay. I think, and yeah. So I think that's not gonna work. Is it gonna work? Yes, it worked. Okay, so it actually did a forward pass. Perfect. That sounds good. Okay, then we'll leave it here. So now we've just whatever that whatever that has done, right? So actually, the forward pass, what does it do? It just does dot whatever. So it just kind of returns something. Can I print it? It's actually doing something. You know, go. I need to move on to something else. Yeah, that's something. Okay, so cool, fine. It's done some. It's just done something. Now we need to do kind of the forward, the backward. Like we need to iterate over all the peak. Peak not all the 75 things. Training samples, blah blah. Kind of move. And do the forward pass to these and the backward pass, and that's it. Let's see. Because essentially, isn't that supposed to just uh, give me like isn't that just supposed to give me like the actual probability distribution? Isn't that fine? Thought is that this? That wouldn't be correct completely. I think if that's this number, it's this number, but I don't want that shape. I definitely don't want that shape. I just want like that shape. So, but okay, we'll get there. We stepping into a bit of the neural network stuff, which is actually, if you think about it, this is very simple conceptually. Well, it seems at least high level simple. Anyway, see you next time.